So the issue I was having with Chrome and this Chrome extension that I was writing and that's monitoring all my pages is that I really wanted to do Comet while doing this. And you very quickly hit a connection limit when you have 100-some tabs open and each tab is individually trying to make a connection to the server. And there's really no way to share that. What am I plugging into? You're set. I just have to pay attention to what I'm doing. So yeah, I hit this connection limit pretty quickly, and I really thought that I've always seen the connection limit as one of the forefront problems in HTTP, and the idea of being able to poll for data and listen for data, this Comet idea, doesn't really scale, and this is something that I desperately wanted to address. And there is a working group out there that wanted to address this issue, the hanging request issue. Hi-Bye working group realized that Comet and the way that we were trying to deal with these large amount of connections was simply not working, not scaling, and was kind of a hack. There's HTTP is a pipeline request response model, and there's just no way to deal with responses that don't get back to us. I'm going to do a quick little tour through some of what these people thought was important. And of course, this screen is absolutely tiny. So let's just look through the Hi-Bye mailing list and see some of the issues that people thought was important. And this will just kind of be a really quick retrospective on what sort of issues people were talking about at the time when Hi-Bye was made. So minimal eventing was one of the first ideas that came up. It was just a random thread saying, how do we get, just talking to the, one of the, anyway, there's a bunch of people chipping in saying, how do we get information on the page? What do we do with all these widgets? This is a similar idea. How do we deal with this, particularly in the context of our 2 connection limit, however many connections we have? How do we get data onto the page in some sort of push assertive fashion? We have one particular opinion, Greg Wilkins, talking about how multiplexing is the way that this is going to be done. And in general, this is one particular way for how connection sharing might be addressed, how we might be able to get around this. This is just from some random java.net article, but it really has, I think, many of the core ideas, and many of the ideas that are talked about here, I think, are items that, well, they are the particular means that I use to implement my own way to address this connection limit. And the idea really is to have some sort of pool being run by, this is particularly talking about server-sent events, which is another way of sending data to the browser. And the server-sent events plan, you have a TCP connection that is talking to each individual page. So this doesn't address the 2 connection limit, but this particular article is saying, well, we can just have a pool, some sort of managed pool that's shared, and then from that shared pool, we can designate and send requests where they need to go. And this is probably the best post I have seen on the list. Jamie Lokier, I love this. He's just talking about what's required for multiplexing, how people would have to, what's going to be required to share a pipe, to get a pipe that everyone can use together. And he's not specifically, he doesn't address the earlier points about the connection, the shared pool that's spoken of here, but in terms of how a shared pool would be implemented and what needs to go into a shared pool and how it would work, how we're going to route that data, this is just dead on. And so it seemed like a good challenge to be able to try and get something working with this, to try and get some sort of asynchronous HTTP live and running. So I wrote a very simple little system. The backend is Node.js implementation, and it's a message router. It's simply a backend. For the backend server, it's a front-end proxy, and it multiplexes connections over HTTP. And so let's look at a test page. This is the test case. The only really interesting thing that's included here is pipe.xhrjs, and that's my implementation of my pipe system to be able to multiplex and get asynchronous HTTP. As you can see, the test case is pretty simple. Let's open an XML HTTP request, let's get some data, and then do something to then when we're done, we're just going to change what the page says. And really simple idea.
Does your pipe.xhr overload the...
It does. That is exactly what it does. It overloads XML HTTP request. And so you get a very simple, easy to use code, and yet behind the scenes, Node.js is routing all of these requests through itself. Here's random useless logs. It doesn't really say anything interesting, but that's Node.js in action. So yeah, like hit it, and we have this data. And you can see that what we're asking for is resource.text. You can see resource.text is fulfilled through, it goes through, there's a bunch of different, this uses just goes through a bunch of different filters, and it gets to the xpipe filter. And the xpipe filter is what implements the xpipe routing. Then we'll look at this, take another view of this data and look at what's happening. So here's the request being sent out. When the request is sent out, it creates its own pipe. It just generates its own random ID for this pipe. And then the response back to it, when it gets the data back, we can see that the pipe, this message is tagged with the pipe again, and there's now a sequence with it. The sequence will just increment each time this particular pipe is used. So it's just, whoops. There's a delay filter in here, so I can just, this will make the request hang for a little bit. It'll just wait for a while, and then I'll be like, oh, here's your data back. We're still running, good. That did not clear what I wanted to. Well, rather than try and demo this, the point of what it's doing is it's creating these individual pipes, and these identifiers, these tags on the messages, these headers, give it a way to address each message. And so rather than have a request response framework, now what we have is we have HTTP sending requests out, HTTP asking, saying, here's this request, and then when a response comes back, the response can be to any message. It's not necessarily going to be in response to the message that was originally, a message that is a reply is not necessarily going to be to the given message from which it was requested.
So you're basically, instead of opening up a dedicated comment connection for every one of those XHR objects, you're opening up one comment and you're basically piping all these other ones through the single connection and ID.
Yep, that is exactly what's going on. It's all being multiplexed, and the way that that is done, mouse, where are you? Hi. All right, so this is weird. I don't have the display on my screen.
Do you have a way to do more than one, but not one-to-one? So right now you went from...
There's no way to have multiple...
down to one. Could you do 5?
Yes, yes. The idea is to take as much advantage of the existing pipelining system as possible, so you can issue a large pipeline of requests and then be able to get them back as in whatever out-of-order system you want. And so kind of the model for this is we'll have like a couple different web pages open here. And then the magic that runs all of this, there's a very simple implementation of a shared router, or excuse me, a shared worker. Shared workers are an HTML5 creation. And the shared worker, the center item here, is talking to each individual page. And what happens is when you look at the XML HTTP request, when this happens, the proxy is talking to the shared worker. it's sending the XML HTTP request to the shared worker, and then the shared worker, on behalf of the page, issues the request over to the server. And so this is going to be our Node.js server. Node. I can't draw. That's no secret.
A Japanese character for awesome?
Yes. So it talks to Node, and then Node goes off and does whatever asynchronous processing it needs to with this request. It does something fancy asynchronous, and then at some point later, back in time, it comes back. The data comes back, and it will come back. Node will send it out over whatever particular TCP connections or whatever HTTP connections are open. And again, it's decoupled, so it's not necessarily going to be the same item back. And then it will get routed back to its original destination. And this allows having this common shared worker is really kind of the key. It is very much. I mean, this idea is really dead on. They were talking about having to handle the per server connection limitation, a shared worker which shares a single event source object can be used. And so it's not a single event source object. It's the shared worker is making a crap ton of XML HTTP requests, but it's getting, whenever it gets a response, it's using that tagging. Do I still have anything in? Oh, I do still have some data. Yeah. It's using each message's individual tag to route it back to the worker. Really.
So the shared worker, that's on the client side, I would assume.
Yes.
Okay, so
it's an HTML5 thing, yeah, client side.
Okay, okay, so that's how I can talk to separate pages.
Yes.
Okay.
Yeah. And the shared worker is really the key thing here that makes all of this possible, is the fact that we can have this delegated responsibility for actually making these connections in a common place for all pages. And so really, the idea for that was, I was talking about earlier, this Chrome extension that I had written where I have every single tab I have open in Chrome is issuing a comment request to my own server. Well, that was, having that shared worker allows me to share that one pool of resources. It's the shared worker is a shared resource pool. And that's all I've done. It's really simple. It's been really fun.
Does the shared workers, do they cache sort of internally using the browser?
The caching I have not yet implemented. I do want to implement caching, but I have to re-implement caching in an application level. So there is work required there.
I'm just wondering if it pulling, because normally if you pull down some code from somewhere, it will cache it.
Mm-hmm.
You can tell it to cache. I'm wondering if you can.
There's a module for that. I'm repurposing there's an app for that.
Very good. That's it. If anybody has any more questions?
Do you have any code up anywhere?
Yeah, code is up, and it is at cgit.voodoowares.com/ cgit's particular about this, actually. Oops. /. The project is pipe layer. I'm laying new pipes for the web infrastructure. I don't know if it's better yet, but it allows me to run 300 common connections, so it's a start.
Is there, I'm sorry, go ahead.
Oh.
Back to what I was trying to ask earlier, and I just asked it wrong.
Oh, I'm sorry.
You've got one shared worker.
Yes.
Is there any benefit, or is there even any capability to have 5 shared workers that would split up 1,000 connections?
I don't think there's really a benefit. You could, if you wanted to, you could isolate the pipes. Like if for whatever reason you wanted, like, I don't know, high security or low security, A or B, you could run multiple shared workers and talk. You need to.
Does it create one shared worker for each target location? Like, my question is, if I wanted to talk to 5 different servers, would I create 5 different shared workers?
No, each shared worker is capable of doing all of the routing for all of the XML HTTP in flight. And so it will, the shared worker will gracefully degrade if you're not running the pipe layering system. So you can access /.com, /.org, and it will still go through the shared worker out to /dot get back and then get routed back to the page. There's no need to run multiple shared workers. It is the new XML HTTP request. It fully tries to emulate it in every way possible, and there's just one shared worker is the model it was designed in that will run, power, and route messages into and out of it for where it needs to go.
So it's a progressive enhancement.
It is a progressive enhancement.
Compatibility back.
Yep.
Presumably comment style stuff in the back.
I'm working, that's one of the things I really would have loved to demo. One of the other big influences for all of this has been reverse HTTP and all the various push systems. I'm really a fan of L-Shift, Tony G, what's Tony's name? Tony G. He had this, L-Shift had a pretty good project called Reverse HTTP where they did a pretty good job of taking like Second Life, Mark, I don't know, was it? The Second Life guys have been doing inverse HTTP for a while, and he took that up and he wrote, so there's like a registration system on one side of it where you're, it's pretty crazy, but he wrote a really nice reverse HTTP system. It has a bunch of interesting features, and that was a big inspiration. And so the piping also, there was a sequence. You can see this.
The short story is that it works today everywhere and works better with new technology.
Using limited amount of pipes. If you have a limited pipe space, it will give you much more pipes. If your server, it will give you a much wider pipe utilization if the server has those pipes available. There's still, I mean, if the shared worker doesn't have an X pipe and doesn't have a X sequence, it doesn't know where to route it, and it can only use native dumb XML HTTP request. It can't use any of the progressive enhancements. So you're still going to be stuck with whatever AJAX limitations you have, comment limitations you already have.
Cool. Speaking of progressive enhancement, like by going through that shared router, would you be able to also like negotiate with the client if it does WebSockets, that kind of thing, or negotiate with the server that you can drop down to a lower level than HTTP?
I don't have any lower levels. This was all really built to extend and embrace HTTP. I really think HTTP is the bee's knees, so that's all that was my only real goal.
It was just something I was curious about, because I mean, there's obviously, even though I also happen to have a little love affair with HTTP, there is a lot of requests, or header overhead, that you can get rid of with WebSockets. I was just wondering if that's kind of...
There is definitely headers that you can get rid of with WebSockets. I tend to abuse headers shown up here, so I haven't done anything with that. I want to actually back up a little bit to the reverse pipe. Speaking to that, one of the features that is implemented or in the process of being implemented, and what I would have liked to, not quite ready for demo time yet, but there is based off of the reverse HTTP work, there is sort of like an Opera Unite-esque reverse router, so that this page right here, this page right here actually has an address on the internet. It has an address on the internet, basically, I guess. Yeah. So that I could issue a webhook. I could go to PubSub Hubbub, hook up this page and say, PubSub Hubbub, you need to notify my IP address. You need to notify my web server whenever you get this data. And then the web server will route that over to this page. So you can have webhooks in your web page. And that's like, webhooks I think are a pretty fantastic solution to being able to do reverse and push. And it really works well because it's a great asynchronous, it's a very asynchronous technology, and it avoids the like long polling notion altogether of comment. It's like, yes, you can just run comment on this and be naive, and it will multiplex your 800 connections down into 2 pipes, 1 pipe, it doesn't matter, 1 HTTP connection. But the real, that's still a hack. There's no reason to keep those connections around. Just when you get data, send it over the pipe, send it back to this pipe. And that's also really a very trivial implementation. There's X sequence, which just grows up as you use the pipe. And again, this is just identification for each message so that the shared worker knows where to route it. There's also the inverse of this is XRSeek. and XRSeek is just that reverse pipe when messages are being asserted to the pipe, and the pipe has no request there. It's data being uploaded. This is actually XPipe and XSeek. Chris Zip, thank you. A lot of this idea came directly from Dojo and XSeek. They have their own XSeek. They don't have.
XID, I think.
Yeah, no, they have XID and XSeek. Yeah.
Or it's XSeek ID, which is, it just identifies, and so you can order your transfer.
Yeah, it's a
HTTP request because HTTP is not ordered and all that.
Right. Yeah. So that's exactly it. XSeek was introduced to be able to, as I'm going to repeat. XSeek was introduced to be able to reorder HTTP requests when they don't come in order. And this is just saying, well, rather than putting them into order, we'll redevise the order. It's a different rendition on the same idea. I can't precisely pin it down verbally for exactly what it is, but it's a similar sort of ordering concept, and that's the implementation. I've walked you guys through most of it. Again, HTML5 on the client side is really what powers this, and then the back end is all some cool Node.js code. And thank you, Raya. That's it. Any questions? Anyone else? I think we're done. Thank you all so much.